Hey there, thanks for joining me again for another video from the Math Doc. We're continuing with our progress on linear equations, continuing with solving multi-step equations, and if you're new to this channel, check out the links below to some of the background, and please subscribe. This video will include just a few simple examples. They are not as simple as the ones in the previous two videos, but they're building on them, and we'll go through them slowly so you see all the steps. And in the next video, we'll finally get into some of our word problems so that you can learn how to build the equations, not just solve them. We'll do that all step by step. So to begin with, a quick reminder that when we look to solve equations or equalities, we have certain properties that we use. Here they are on the right. There we have the addition property, where we say if we add the same number or the same variable to both sides of the equality, then the equality holds. So if A equals B, then A plus C equals B plus C, where we've added the same number, C, to both sides. The same goes for the property of subtraction. Again, we have to subtract from both sides the same number. We also have the multiplication property, which is if A equals B, then A times C equals B times C. And for division, if A equals B, then A divided by C equals B divided by C. Another reminder is that when we try to solve an equation, a linear equation, what we are doing is we're going to use these operations, but we will be looking for inverse operations, so that if we have addition in our equation, well, then we will try to use subtraction. If we have multiplication, we will try to use division, and vice versa. If we have subtraction in the equality, then we will use our addition property. If we have division in our equality, we will use the multiplication property. And I will go through this and show the steps. But essentially what we're trying to do is we want to isolate our variable. That is our goal, because once we isolate our variable, usually it's x, but it can be y or d or any other letter. Once we isolate our variable, we basically have solved, because we can see what x is equal to. So when I say isolate, I mean bring it to one side of the equality. So we have x equals, and we may have here an expression with numbers, but as long as x is on its own here, we can evaluate this and we know what x is equal to. The various steps in isolating the variable will be to use these properties of equality, so we will use them, but also we will use various other properties to help us simplify the equality. So we will go through three examples in this video, and these will help us understand how these properties are used, and how to use them and when to use which property. So let's get started. Our first example here will be 6 times, in parentheses, x minus 2 equals 18. Now we're starting with this example, which is actually quite similar to one of the examples we did in the previous video. The reason we're starting with this is because there are two ways we can solve this. One way is we can first simplify, and the second way is by first using division property. So I will go through both methods so that you have an idea of how to use both of them. So let's start by first going with the simplification. So let's start with that option. So we have 6 times x minus 2 equals 18. Now to simplify, let's use the distributive property to open up these parentheses. What the distributive property says is that when we multiply a parentheses by a coefficient, we open those parentheses by multiplying each one of the elements inside. So we have 6 times x minus 6 times 2. And we have a minus because there's a minus in there, and that should equal 18. So let's remove the parentheses. 6 times x equals minus 6 times 2 is just 12 equals 18. Now let's use our first property, which is the addition property of equalities. Okay, addition property by adding 12 to both sides of this equation. So we're adding the reverse operation, right? The inverse operation to minus 12 is add 12, and we're adding the same number to both sides of the equality. So we get 6 times x minus 12 plus 12 here, or it's just 0, equals 18 plus 12, and that is 30. So in the previous video, I went through an intermittent step where I wrote out this addition of minus 12 plus 12, but I think we're at the point where now we can do that within one step. So we have 6 times x equals 30 because the 0 obviously is cancels. What is our next step? We will use the division property. So we are looking at the inverse property to 6 times x here, right? So it's 6 times. So let's divide by 6. To divide by 6, I will write it out as a fraction. Again, division by 6 is the same as multiplying by a sixth. So now what do we get? We have 6 times x over 6 equals 36s. The 2 6's here cancel, right? They contract. 6 6's is just 1, and 36's is 5. So 30 divided by 6 is 5, and we get x equals 5. Now, the next step is to really check our result, right? We check by substitution. So we take x equals 5 here and substitute that in our equation. Our equation was 6 times x minus 2 equals 18. So 6 times 2, x minus 2 equals 18. Okay, and x equals 5. So we're going to put 6 times 5 minus 2 equals 18. And the equality here is still being checked. Now 5 minus 2 is just 3, so we have 6 times 3, which is 18. So this is correct. So by checking, by substitution, we made sure that we solved the problem correctly. Now, as I mentioned in the beginning, we have 2 methods of solving this. They're basically similar, it's just that we take different steps first. In the second method, we will use the division property first. So let's go ahead and do that. So we have 6 times x minus 2 equals 18. So we would like to use the division property. Now, why do we want to use the division property? Well, we can see that we have here 6 times the parentheses. So our first step will be to isolate not x itself, but to isolate what's inside these brackets, what's inside the parentheses. The inverse operation to times 6 is just divide by 6. So we'll go ahead and divide both sides by 6. Okay, so what do we get here? We get 6 divided by 6 times, in parentheses, x minus 2 equals 18 sixths. 18 sixths is just 3, and 6 sixths is 1, right? So now we have 1 times x minus 2 equals 3. Let's open these parentheses because the coefficient is 1. We just have x minus 2 equals 3. Now we will use, in order to isolate our x, we will use the inverse operation to minus 2, which is just addition of 2, right? So we'll be using the addition property. And we remain with x minus 2 plus 2 is just x, right? These two cancels. And we have 3 plus 2, which is 5. So x equals 5. Let's look at our second example. This one is going to be a little bit more complicated, but again, we'll do every step and we'll go through it together. So our next example is 5 times x minus 3 equals 2 times x. Okay, so why is this more complicated? Well, it's more complicated because now we have our variable x on both sides of the equality, plus we have these parentheses, so it is a little bit more complex. However, if we take one step at a time, we will be able to solve this equality as simply as we did the previous one. So in this case, doing the first step of division by 5 may not make sense because we still have the 2x here. So let's start by simplifying. So our first step will be simplification by using the distributive property. Okay, again, the distributive property has to do with opening parentheses that are being multiplied by a coefficient. So we have 5 times x, and then we have minus, because we have a minus here, 5 times 3 equals 2 times x. Let's write that out more simply. So we have 5 times x minus 15 equals 2 times x. Okay, so now we do have a simpler form, and our next step will be to try to isolate our variable by moving things around. So first of all, we like to group together similar objects, right? We group together similar items. In this case, we really would like to group together all our items that have the variable. So all parts of this equation that have the variable x in it should be on the same side of the equation. So in order to do that, let's use the subtraction property, okay? To do that, we will subtract 2 times x from both sides of this equation. So what do we get? 5x minus 2x. And I'll write that out fully because I know that this might be the most confusing part of this whole example. Minus 15 here equals 2 times x minus 2 times x. Okay, now what do we do? Well, let's look again at the similar elements, right? We have 5 times x minus 2 times x. Again, x is a variable, and it could be anything. But we know that this x is the same as this x. So if x is an apple, or x is a bag of apples, it is similar. And therefore, if we had 5 of them, 5 of these x's initially, and now we're taking away 2 of them, we remain with 3 of them. So that is the result of that subtraction. We have 3 times x minus 15 equals, and here we have 2 of this x minus 2 of the same x. So whatever x was, since we added 2 and then subtracted 2 of it, we remain with none, which is 0. Okay, so now we have a much simpler equation, and again, we will use one of our properties. Here we're going to want to use the inverse property to minus 15, so we will add 15, right, to both sides of this equation. So addition property. We've added the same number to both sides. So even when we have 0 on one side, if we are going to add something to one side, we have to add the same number to the other. So now we have 3 times x minus 15 plus 15. They cancel, right? equals 15. 0 plus 15 is just positive 15. And now, again, we have to use the inverse property to multiplying by 3. That would be division, right? We will divide by 3 and use the division property. So we write that out as a fraction here. So we divided by 3 by writing out a fraction with 3 as the denominator. And now we get the result. Since 3 over 3 is just 1, we have 1 times x equals, and 15 divided by 3 is just 5. So x equals 5. And that is our result. Now, obviously, we should always check, and we will check this once more. We will check this result. Let's look at our original. Our original equation was 5 times x minus 3 equals 2 times x. So 5 times x minus 3 equals 2 times x. And now we will substitute our result, x equals 5, into this equation. So we have 5 times, and now instead of 5, instead of x, I will write 5 minus 3 equals 2 times x. Again, we will write 5. So since we have x on both sides of this equality, we have to substitute our result in both sides. Okay. So we have 5 times, 5 minus 3 is just 2, and that should equal 2 times 5, and it does. These are equal both to 10. So we checked our result, and it is indeed correct. Our final example for this video will not be more complicated. It will be just a little more involved. So our example, our third and last example, is 5 times x minus 1 plus 9 equals 3 times x plus 7 minus 2. So our first step will be simplification, and we will use, again, the distributive property, which helps us open up parentheses. So let's do this step by step. So first, we'll do 5 times x minus 1. So we have 5 times x minus 5 times 1. That's our first element. Then we will add to that the 9, and by that we have dealt with our left-hand side. That equals, okay, now we'll use the distributive property again for 3 times x plus 7. This will give us 3 times x plus 3 times 7. And again, we have a plus here, so we get a plus here, and we have a minus here, so we get the minus here. And then finally, our last element on the right is minus 2. Now to group together similar elements. So let's write this out again. We have 5 times x, I can remove those brackets, minus 5 plus 9, that is plus 4, equals, and we have 3x here, 3 times x. We have 3 times 7, which is 21. I'll write that out here. 21 minus 2 is 19. Okay, so now we have a much simpler equation, and now we will use our various properties in order to group the different elements. First step, let's use the subtraction property, okay? Because we would like to move this 3x basically to the other side. So we want to remove our variable from the right-hand side. So the inverse operation to plus 3 times x is minus 3 times x. Okay, so let's do minus 3 times x and minus 3 times x on the right, and let's write this out. Now we have 5 times x minus 3 times x. This will give us just 2 times x. Again, regardless of what x is, if we have 5 of it, and then we take 3 away, we're left with 2 of x. So if x is a bag of flour, and we had 5 bags of flour, we took away 3 of them, we're left with 2. What if X was 5 balloons? Well, we took away 5 groups of 5 balloons. We had 5 groups of 5 balloons. We take away 3 groups of 5 balloons. We're left with 2 groups of 5 balloons. Okay, and then we have plus 4 that comes down from here equals. Now we had 3x minus 3x. That will give us 0 because we took away all our variables from this side, plus 19. Okay, so hopefully this is not too confusing. I just take every element from each side and I bring it down to our new equation. Okay, so now we have all our variables on this side, right, on the left, but we still have what we call constants, numbers that don't change. That's why we call them constants. We still have constants on both sides. So let's use the inverse operation to plus 4. That would be minus 4, right? So we will subtract 4 from both sides, and that means we're using again the subtraction property. And what do we have left? We have on the left hand side we have 2 times x. The 4 minus 4 cancel, and 19 minus 4 on the right equals 15. Okay, we're almost done. What is the inverse property to 2 times x? The inverse is let's divide by 2 or multiply by a half, right? So we do that, divide by 2, divide by 2, and our result is here. So 2 divided by 2 is just 1, so we have 1 times x equals 15 divided by 2. I'll tell you what that is. It's 7.5, and you can check that on your own. The 1 here is not, it's a multiplier, and so our result is x equals 7.5. And of course, we will need to check the result. Let's check this result by substitution. Let's go back and write down the equation. Our equation was 5 times x minus 1 plus 9 equals 3 times x plus 7 minus 2. Okay, let's substitute. For x, we'll write 7.5 instead. So 5 times 7.5 minus 1 plus 9 equals 3 times 7.5 plus 7 minus 2. Okay, 7.5 minus 1 is 6.5. And 7.5 plus 7 is 14.5. Let's write these out as improper fractions. That'll help us with the solution. So an improper fraction we get by multiplying 6 by 2 and then adding the 1. So this is just 13 halves. And this here is 29 halves. Okay, so let's write that out. We have 5 times 13 halves plus 9 equals 3 times 29 halves minus 2. Okay, so we know how to do this as well. So let's write this out. 5 times 13 is 65 halves plus 9. How many? That is 18 halves, right? We're writing it all out as improper fractions. 3 times 29 is 87 halves minus 4 halves. So what do we have here? Here we have 65 plus 18 halves. 5 plus 8 is 3, so that's 83. So we have 83 halves on this side. Is that equal to what we have on the other side, which is just 87 minus 4, which is indeed 83 halves. So yes, we got the right result, and we can be convinced that our result is correct by checking. So thanks again for joining me for another video. The next video will focus only on word problems. We will start with simple ones, and we will work together to build our equations and then solve them. And by the end of next video, you will already have a good grasp of how to build an equation from a word problem. Thank you for joining me again. If you're new to the channel, please subscribe, comment below if you have specific questions, and of course, like. See you next time.